out the questions here, the graphing these. And what's best to do is to try to graph them and then come down to the answer choices and see if you can match. All right, so first let's just make sure we get what the tangent is, right? So whether we're using tangent of theta or tangent of x, it doesn't matter. It just means that our input is the angle and our output is the tangent of that angle. You got to keep that track in your mind. So unit circle is always going to help us. I drew the triangle to remind you that these values here, right, this is a triangle. When we have a unit circle, it means the radius of the circle is 1. So that means the hypotenuse is 1. And these are x and y values, which means that you have an x value that is square root 2 over 2. That is this value. And you have a y value. The vertical distance is square root 2 over 2. So that means that the tangent, which we should remember, tangent equals, we can think of it as the opposite over the adjacent, but that also is the sine divided by the cosine, and the tangent of 45 degrees, right, is the sine is square root 2 over 2, and the cosine is square root of 2 over 2, so that's just going to equal 1. And then if we go around here, this is not a nice value because I have a half divided by square root 3 over 2, right? So these are fractional values, they're decimals, they make it hard to graph. But when I get to here, if I go to the tangent of 90 degrees or pi over 2, let's think in radians. Now pi over 2, I'm going to have the sine, which is 1, divided by 0, which is not possible, so this is undefined. And at these values, we get asymptotes. So we should know that. And we're going to get these asymptotes are going to repeat every pi, right? Because if I go to have the tangent of 3 pi over 2, I'm going to be back at the same point. I'm going to have negative 1 divided by 0, and that is going to be undefined. So I can see, and I can also see that I'm going to get the tangent of 1 again over here because I'm going to have negative square root 2 divided by over 2 divided by negative square root 2 over 2, 1. So we have to remember then that our period of the tangent function is just pi, right? These things are repeating every pi. So now let's just go into Desmos a little bit. All right, let's adjust. We have these ordinal numbers here, which are not very useful in graphing this because we're thinking in radians. So let's make it be from negative 2 pi to 2 pi. And let's say our step is going to be pi divided by 2. And then we can just make this 10 to 10 and make our step be 1. All right, so now we can say, let's say y equals a, because we can change that value, tangent of bx. And we're going to put in some sliders, right? And first we're just going to have this be 1 and this be 1, and we can see exactly what we expected. Every pi we're repeating, right? The period is pi. The asymptotes are occurring at pi over 2, right? Every pi over 2 I have an asymptote. Now if I change the value of a, it's going to make it grow quicker, right? But if I make the value of a be negative, look what happened. It flips about the x-axis. Now, what's super interesting, let's set a back to 1, is that because this function is symmetrical about the origin, right? If I reflect it about the x-axis or the y-axis, I get the exact same change. And that's what happens if b becomes negative, right? If b becomes negative, we have negative values of b, we get the same reflection. So in this case, if a is positive and b is negative, we end up with the same reflection as if b was positive and a was negative, right? We can see exactly the same thing happening. All right, so let's leave a at 1. We got to start to think about what happens as the value of b increases. Do you see we start getting more and more of these asymptotes? And that's because the period is pi divided by b. That value of b is going to help us know how quickly this graph repeats. Because think about what it's happening here. If I say the tangent of some number times x, right? That means that it's whatever the angle is, I'm multiplying it by 2. So it's kind of like speeding it up around the unit circle. It's making it repeat faster. And if I have a fraction of b, right? So it's not quite 1. I can see that it starts to repeat slower and slower and slower, right? That is the fractional value there, because if I'm multiplying it by a fraction, I'm really slowing it down how fast it's going around the unit circle. So this one, right, you're going to see the repeating asymptotes at pi over 2, right? Every pi over 2, you're going to have an asymptote. This is going to make it, what's going to happen, right? Find the value of b. Pi divided by b is going to tell you how quickly you see the graph repeating. All right, let me know if that helps.